All right, guys, 2.4, rates of change, and then also tangent and normal lines. So normal means perpendicular, so you should write that down for yourself, okay? Transversal also means perpendicular, but I don't think we talk about that in calculus, but you did in pre-calculus. So normal, transversal, those are perpendicular, okay? All right, so we're going to start with different kinds of rates of change. So the average rate of change, this one you guys know. So average rate of change is old school slope. I call it old school. I call it OG slope because I'm old like that. And then it's basically, you know, you have a point and another point. It's a slope of a secant line, right? You find the slope of 2 points and then you plug it in, y minus y over x minus y. So you know all that. So you're going to make a note that this is old school slope. I'm going to say that a lot, okay? OG slope, old school slope, you know, baby slope, okay? And then there's the slope that we were talking about when we were talking about, was it a roller coaster ride, right? Imagine you're on a roller coaster ride and then you have this 2x4 on your head, remember? So that is instantaneous slope. So that is not the same thing. Instantaneous slope is when you're going to a specific, it's 1 point. It's a slope of a curve at 1 point. So it's the slope right here. So if we find the slope to this, let's say it's a parabola, right here, it's gonna look something like this. So this formula is basically saying that you can take y's and you can subtract them. And then if you try to do this, so like, I know this looks weird, but like there's f of a, there's f of a plus h. And we're trying to make h, we're trying to make this length h as small as possible. We're trying to make it go to 0 so that we can just like basically find f of a, okay? So we are basically finding the slope at f of a. So at that x value of a, like right here. I made it over here because, you know, I wanted to be in the middle. But basically we're trying to get h so small, h is going to 0. So it's a slope at 1 point specifically, like at the very top of the roller coaster, at the very bottom of the roller coaster. So that's going to be different than old school slope because old school slope goes through 2 points. This is at 1 point. So slope of a tangent line. A tangent line, if you remember from geometry, tangent to a circle is when you're touching the circle at one place. So that's a tangent line, okay? Different than like sine, cosine tangent. This is a different tangent, which I know is kind of annoying. Sorry, it's just the way it is. Okay, so how do you do that? We literally use this formula. I'm going to keep this kind of on the screen. So let's say you're given this question. Okay, find the slope of the parabola at point 2, 4. I like to circle or highlight like the actual thing that I need, okay? So find the slope, and then after we find the slope, we're going to write an equation of the line using the tangent line and the normal line right at that point. And then I'm going to draw it for you too when we finish, okay? So the very first thing we're going to do is find the slope. So we're going to use that formula. So using this formula, I'm trying to find it at f of 2. So here I have 2 plus h, and here I have 2, right? So a plus h, and then a. So f of 2, I'm going to use this, all over h. So it's the same formula. You're going towards 0. You're going to notice that I'm going to write this limit over and over again until I actually find the limit, okay? So you actually have to do that. So let's see. I'm going to do one step at a time so you don't get overwhelmed. So the first thing I'm going to do is go ahead and plug in. And then when I plug it in, I actually, so right here, f of 2 plus h is going to be, what are we plugging into? We're plugging into something squared, right? So normally it's x squared. So instead of x, it's going to be 2 plus h. So it's 2 plus h quantity squared, okay? And then f of 2 would be 2 quantity squared. Also, you already know what f of 2 is. They tell you it's 4. So, you know, you can just write 4. But I wanted to show you this is the quantity squared. Here's a quantity squared. Here's a quantity squared. I still have my minus. I have my h on the bottom. And then in my next step, okay, I actually squared it. So I FOILed this and I got this. I squared it. I got a 4. You're going to subtract. The 4s are going to subtract away. You get that? You can kind of imagine what's going to happen after that. Do I have another step? I do. And then I can divide away one of these h's, because right here, right, divide away h, I get this. I still have, notice I still have limit all the way down. And then I plug in the 0 and I get 4. My slope is 4. So did I write that? Oh yes, equals 4. That's the slope of my tangent line. Okay, so 4 is the slope of my tangent line. That's my instantaneous rate of change. And then for the tangent line equation, I had my 2, 4, which is a point. I had my slope of the tangent line, which is a 4. So here's point slope. And then I just like leave it. That's it. That's my answer, point slope. So my point was 2, 4, my slope is 4. And then my normal line is, you know, exactly the same thing, except normal lines are perpendicular, so I have a perpendicular slope, right? So I have 3 answers. This one, tangent line, normal line. Okay, I'm gonna try again. We're gonna try again. So number 2. So number 2, it says find the slope. Oh, I wanted to show you a picture. Okay, I'm gonna pause this for a second. I've never done this before. Okay, so I want to show you a picture. So I drew y equals x squared, and then I found the slope of this curve right at 2, 4. The slope, if I was going to draw the slope, if I want to draw a tangent line, would look something like this, right? So there's my tangent line. So here's my tangent line. And then my perpendicular, my normal line, so that's A. And then you can see the slope is very, like almost vertical, because the slope is 4. So that makes sense, right? The slope was 4. And then my normal line would be, I take that tangent line, I make a 90-degree angle right through that same point. And this would be my normal line. So just so you can kind of see what we're actually finding. We're finding a slope, and then we're making a line using that slope through whatever point, and then a normal line would be perpendicular to that original tangent line. Okay? So here is number 2. Number 2, it says, sorry, you can kind of ignore the stuff on top. So number 2, I wrote myself a little note. This says the slope of that curve at x equals 4. Well, it'd be really nice if you had a point. So how do you make a point? You plug in the 4 and you get 1/2. So there's your y value, okay? Then you're gonna find the tangent line, find the normal line, same thing. All right, so we're gonna start with your original function that you plug into your limit. So here's your 4 plus h minus f of 4 all over h. All right, now I'm going to use these, and I'm going to plug 4 plus h and plug 4 into here. So I go ahead and plug it in, and I see 2 fractions, and then I see this h on the bottom. Okay, technically there are 3 fractions. I'll say that again. There are 3 fractions. There's a fraction here, there's a fraction here, there is a fraction here. This is an h over 1. So there are 3 fractions here. How do you deal with a complex fraction, which is a fraction of a fraction? You multiply by LCD. What is the LCD? The LCD, there's a 1 under here, there's a 4 minus 2, and then technically there's a 2 plus h. Well, 4 minus 2 is just 2, right? So there's a 2, And then there's 2 plus h. So those are your denominators, 1, 2, and 2 plus h. So I multiply the top and bottom by all our denominators, and then our denominators are 2 plus h, 2, and 1. So here's my 2 and 2 plus h, okay? The 1 I don't have to deal with. And I multiply it because there's 3 fractions. Remember 3 fractions? I multiply it 3 times. And then when I multiply it 3 times, if I multiply this with this is over this, I cross, I get a 2 left over on top. So that's what's happening here. That's why there's a 2 here. Minus, if I multiply this with a half, the 2's divide away, I get h plus 2 on top. Remember, it was a minus, so you have to have minus parentheses. Be careful. On the bottom, I have my h, I have my 2, and then I have my h plus 2. Just be careful when you're working at it, okay? You just have to be careful with these fractions. Okay, so I have this. I'm going to go ahead and subtract, distribute that negative, and then I get that. And then, I'll go like this. And then I see there's an h on top, h on the bottom. I can divide them away. And after I divide them away, that's when I'm going to go ahead and plug in my 0. So after you divide the h's away, you will always be able to divide it each way. You can go ahead and plug in your 0, and then you get negative a fourth, and then you use that negative a fourth, and you use your point, 4 comma 1/2, to write your tangent line and to write your normal line. Okay? Okay. So the other ones you should try on your own, but you can, you know, if you need help with it, I'm happy to help you with it, and you can listen to me talk about it. But try it on your own, okay? So average rate of change, average rate of change. You have to realize average rate of change is not a tangent line. Average rate of change is not a, instantaneous. So what do you do? And especially because they give you this interval of 2 x values. Oh, they want me to use old school slope. So you literally just plug in old school slope, right? So you find f of 2, plug in 2. You find f of 0, plug in 0. And then you do 2 minus 0 on the bottom, right? Y's over x's. So just, be careful with the question. Okay, I think it's the next one that seems different, but it's the same. So this says, find the falling speed. Okay, it seems different, right? But it's not. So an instantaneous rate of change, we also can refer to as speed. Basically, if they say find the speed, you're finding that instantaneous rate of change. You're finding your slope at one place, okay? So find the speed of a rock at t equals 1, and that's how you know also it's instantaneous. They give you one time value. They give you one x value. This is t instead of x, same thing. Given this is the position of the rock in feet, I added that in. Okay, so then try this one on your own, but then slowly just kind of check your work. So you have that, plug it in, and then you plug in. So instead of 1 plus h, or instead of t, you have 1 plus h. And then instead of t, you have a 1, right? And then you keep going on the top and bottom. So you multiply everything out on top. You get this. Do I have another step? Oh, I have 2 steps, sorry. You multiply everything out on top. You subtract the 16s. Eventually you get this. You divide your h's away. Eventually you get this. And then you plug in your 0, and then you get that. Notice limit every time. Make sure limit every time. Okay? And then final answer, how come I need this as my answer? Well, this is speed. So when you're on in a car, it's like miles per hour, right? So it's in feet. So this is seconds per feet. Miles per hour, miles is the time. And then, no, miles is not the time. I'm crazy. Feet would be like miles. So instead of miles per hour, I have feet per time, okay? Oh, there you go. I always think miles per hour, that helps me. But then that's how I plug it in, okay? So feet and time. All right. On the back is such a good one. Such a good one. So it says at t equals 0 seconds, a diver jumps off of a platform, a diving board that's 32 feet above the water. Okay, so you know what that looks like when a diver is above the water, okay? Find the position of the driver. And then the position is given by, okay? And then you get asked a couple questions. So here's your position. This is all you have to worry about. You don't even have to worry about this original stuff. This tells you feet. It tells you seconds. That's really all I care about. But so that you understand what's happening, it's nice to draw a picture. I'm going to draw a picture with you. Actually, you can try it yourself. And then on the right side, I'm going to show you. So you have a diver, and they're jumping. I'm going to go like this. You have a diver, and they're jumping, right? So you have like water, you have a diver, they're like, woo, yeah, I'm going to jump up, and then it's going to come back down. And then this is time equals 0. He's 32 feet, or she's 32 feet above the water. I see time equals -1, but I'm going to cover that for now, so you don't know that yet. This is time equals, we don't know. Okay, so it takes a certain amount of time to get down here. This is all we know for now. Okay, the first question is, when does the diver hit the water? So when does the diver hit the water? So the time that he hits the water is going to be right here. That's the time. But what do we know about right here? Well, right here, this is 32, which means this is 0. This is 0 feet above the water. So what we want to do is we want to plug into the original equation 0 equals. And then you will always be able to factor. So I divided by -16, and then I factored, and I get 2 answers. I get 2 and -1 for t. Well, obviously, -1 doesn't make sense, but we want to understand what that means. So it takes 2 seconds. All right. So then over here, I say it takes 2 seconds for that to happen. Okay, 2 seconds. So this is 0 seconds. This is 2 seconds. What does that -1 mean? That -1 is basically if she had started here and jumped up, it would have taken 2 seconds to get here, and then it would have taken, some time to get up here and some time to get up down back here. Okay, so this is actually like before he starts. This is -1 second. Okay, there's a lot you can get from this. This is a parabola. This is -1. This is +2. You can tell me right now when he's up here. Come on, you can do it. You can tell me right now when he's up here. This is -1, this is 2. This is a parabola, which is symmetric. -1 and 2. Oh, if this is -1 and 2, this is 0 and 1. This would be 0.5. He's up here. It takes him half a second to get up to the top, to the vertex, and then another 1.5 seconds to get back down here. Okay, so you find out so much information just from that first question. Okay, and realizing, like I said, this is height equals 0. That means S of t equals 0 because S of t stands for position. So that's the height, okay, above the water. All right, the second question. What is the diver's velocity at impact? We want to know his velocity, and we want to know that at time equals 2 because that's when he impacts the water. So in order to do number 2, this part, B, you have to do A, right? So that's why I put a little arrow. Okay, so this is velocity, which is a kind of speed, all right? So velocity is still like miles per hour, whatever. So I'm going to do the same way I did before. I'm going to go ahead and plug it into my limit. And then using this equation, which seems, a little bit harder, right? Using that equation, I'm going to plug it all in. I know it seems crazy, but instead of t, I have to use 2 plus h. So c, instead of t. And then f of 2, I know f of 2, like literally if I plug in 2, I know from this problem I would get 0. So that's why I did -0, right? So if you plug 2 into here, like a sucker, because you're wasting time, then you get 0, and that's why I have 0. Over h. And then I multiply everything out. So you FOIL this, and then you distribute, and then I start, subtracting or whatever I need to do. And then I get this, and then I see a bunch of h's, and then I keep going. Whoop. And I get this. And then I can divide by h, and I get this, and then I can plug in 0, and I get -48 feet per second. So here's all of it. And then I wrote a little note. Velocity can be negative, speed cannot. That's the difference between velocity and speed. Technically, velocity is your instantaneous slope. So if you're finding instantaneous slope, that's actually exactly what velocity is. but speed is the positive version of velocity. So if I ask you for the speed, you would say, oh, the speed is 48 feet per second, but the velocity is negative 48. How come the velocity would be negative? Because the velocity is the slope. And right here, when he's going down, remember if you're sitting on a roller coaster, you have a zero slope here, and then you start to have a negative slope. So when you have a negative slope, that's why the velocity is negative. Okay? And then it says, what is the diver's velocity when he or she reaches the maximum height? I want you to think about that, and the answer should come pretty quickly. What is the velocity when they reach their maximum height? They're really asking what's the slope, guys. So what's the slope up here at the top of a roller coaster? Oh, it's 0. It's 0 feet per second, because instantaneous slope at the vertex is always going to be 0, because at the very top and bottom of a roller coaster, you're always going to have a 0 slope. You're sitting straight and you see the horizon on a roller coaster, right? And also, like we discussed, that is where t equals 1/2, and you can tell that by taking the middle, the midpoint of -1 and +2, and right in the middle of that would be your vertex, which is t equals 1/2. Okay, so many questions can be answered by just, factoring. And then, obviously, by doing that too. Okay, so you're going to give it a try. Your homework is written on the, Google Classroom. Good luck. I will see you at student support if you need it.